Well, hello and welcome to this exercise on word problem. Again, this is typical overlap for higher and foundation tier. We're looking at level 4, level 5 in the new 1 to 9 in the new 1 to 9 system. Here we go, and it says there are 20 rings stacked up in 4 towers, and the first tower has 3 rings less than the second tower. The second tower has 2 more rings than the third tower. The fourth tower has twice as many rings as the second tower. That is, the question then is, how many rings in each tower? Now, I'm going to do this using 2 methods here. Now, whatever happens, whichever method you use, you need to know where to start. And the word second occurs 3 times, whereas the word first, third, and fourth occurs just once only. So it wouldn't seem that the second tower will play a pivotal role in how we solve this problem. So for method 1 will be the trial and improvement method, and this is the method you use if you're in year 6 or year 7 trying to solve this problem. Okay, now to start with, I'm going to start from the second tower, and for the second tower, I'm going to assume that the second tower has got just 1 ring, and that's the ring there. Now, will this be part of the solution? Okay, let's check. Now, don't forget that the first tower has got 3 less rings than the first tower. So, if the second tower has got, if the second tower has got only 1 ring, it then follows that the first tower has got to have 1 minus 3, and that's equal to -2. And you cannot have negative 2 rings in this situation. So, 1 ring only in tower 2 is not part of the solution to this problem. Now, let's try 2 rings in tower 2. Now, we've got 2 rings in tower 2. Now, is 2 rings in tower 2 part of the solution to this problem? The answer is no, because similar to the first one, 2 minus 3, because tower 1 has got 3 rings less than tower 2. 2 minus 3 is -1, and you cannot have -1 ring. It's impossible, you can't do that in this situation. Right, so now we then try 3 rings in tower 3, which is this one here. Now, the same process again. If we got 3 rings in tower 3, it then follows that for tower 1, you're going to have 3 minus 3, which will give you 0. So it's quite possible to have no rings at all in tower 1. So that's a possible problem. A possible solution. Now, if that's the solution, that is, if having 3 rings in tower 2 is a solution, then for tower 3, we're going to have 3 minus 2 rings as 1. So that suggests that in tower 1, we're going to have 1 ring. Sorry, in tower 3, we're going to have 1 ring, because tower 3 has got 2 rings less than in tower 2. So tower 3 is going to have just 1 ring. And if tower 2 has 3 rings, tower 4, so hang on, just get my pointer. Right. If tower 2 has got 2 rings, then tower 4 must have 6 rings, because tower 4 has got double the number of rings in tower 2, so it's going to be 6 rings. Now, if we then add 6 in tower 4, plus 1 in tower 3, plus 3 in tower 2, plus 0 in tower 1, we have 10 rings altogether, and 10 is not equal to 20 because we're looking for 20 rings. So having 3 rings in tower 2 is not part of the solution. Okay. Now don't forget, in the current GCSE system, you must give reasons. You must give some reasoning. Okay. Now let's try 4 rings in tower 2. Now if we got 4 rings in tower 2, now don't forget that tower 2 has got 3 rings more than in tower 1. So tower 1 has got to have just 1 ring. 4 minus 3 will give it 1. And tower 2 has got 2 more rings than tower 3. So tower 3 is going to have 4 minus 2, that will be 2 rings. And if tower 2 has got 4 rings, it then follows that tower 4 is going to have double 4, which is 8. So tower 4 is going to have 8 rings. Okay? So if we add 8 in tower 4 to 2 in tower 3, 8 in tower 4 to 2 in tower 3 to 4 in tower 2 and to 1 in tower 1. The answer would then be 15. And 15 is not equal to, we're looking for 20 rings now. So the solution in this problem does not include 4 rings in tower 2. Now, why don't you try 5 rings on tower 2 and see if you get the answer? Okay? Now, that's method 1. And that's the trial and improvement method. Now, let's try algebra in let's try algebra in the next slide. Okay, now that was slide 1, and that was the trial and improvement method. Now, we've now copied the question again from slide 1 to slide 2. Okay, right, now this time around we're going to try the algebraic method. Again, don't forget that tower 2 has got an important role to play in this problem. So we again start from tower 2. Right, algebra. And then we say, let the second tower have x rings, because that's what we're going to start from. Now, if the second tower has got x rings, and the first tower has got 3 rings less than the rings in tower 2, so we then have that for tower 1, we're going to have x minus 3 rings for the first tower. And don't forget that the second tower has got 2 rings more than in tower 3. So tower 3 is going to have x minus 2. Okay, rings. So that would be tower 3. Now, tower 4 has got double the number of rings in tower 2. So if tower 2 has got x rings, if you double x, you get 2x. So tower 4 has got to have 2x rings there. Now, we're going to add up all these rings now, the x in tower 2 to the x minus 3 in tower 1, the x minus 2 in tower 3, and 2x in tower 4. And that's what we got here. So we've got x minus 3, get my pointer again, sorry about this, I apologize. Where is it gone? Right, sorry. Right, so I got x minus 3 for tower 1, and I got x for tower 2, and I got x minus 2 for tower 3, and then I've got x minus 2 for tower 3, I do beg your pardon, and then 2x or double x for tower 4. And if we add all this together, we should get 20 rings. Okay? Now, we now collect like terms. So we're going to look at the x's first. How many x's have we got? So we now have 1x from there, and then 2x, x plus x give us 2x, and then plus another x to give us 3x. And if we add 3x to 2x, you get 5x. What about the numbers? We got minus 3, or negative 3 if you like, and negative 2 will give us negative 5 or minus 5. So now what we then have is 5x minus 5 is equal to 20. Now, we want to get rid of the minus 5 on the left-hand side. And to do that, we add 5 to make it balance. Add 5 to both sides. And that's what we got here. So we now add 5 to both sides now. On the left-hand side, 5 minus 5, or minus 5 plus 5 will give us 0. So the minus 5 plus 5 on the left-hand side will cancel out. So on the left-hand side, we now have 5x, and on the right-hand side, we've got 25, because 20 plus 25 will give us, 20 plus 5 will give us 25. So 5x is equal to 25. So you want to multiply 5 by a number to give us 25. Or if you like, if you divide 25 by 5, will give us the value of x. So in this case, x is 5, because 5 times 5 is 25, so x is 5. So the number of rings in tower 2 is now 5 rings for the solution to this problem. Now, if that's correct, then for the first tower, because that's got 3 rings less than in the second tower, okay, now 5 minus 3 will give us 2, so we've got 2 rings in tower 1. For the second tower, we've got 5 rings, because that's x, we know that already, so x is 5. So for the second tower, we've got 5 rings. And for the third tower, that's going to have 2 rings less than in tower 2. So for tower 3, we're going to have 3 rings, because 5 minus 2 will give us 3, which means that in tower 4, we're going to have 10 rings. And if you add 2 to 5, which is 7, if you add 2 to 5 and 5, which is 7, 7 to 3 will give you 10, 10 plus 10 will give you 20. So we now have 20 rings now. So that is our solution. So tower 3, tower 1, 2 rings, tower 2, 5 rings, tower 3, 3 rings, and tower 4, 10 rings. If you add all those up, you get 20 rings. So we're now correct. Thank you for watching, and please subscribe. See you again sometime, and bye-bye now.